Hello, my name is Dat Dang, an application manager for the Zero Transceiver product at MaxLinear. In this video, I will provide 4 tips to maintain an RS-485 communication without any data loss. Tip 1. Refer to the TIE EIA 422B Annex A for a guideline for cable length versus data rate when designing your RS-485 system. This curve is based with empirical data using a 24 AWG unshielded twisted pair copper conductor with a capacitance of 16 puff per foot and terminate into a 100 ohm resistive load. In region A, the maximum distance is determined by the DC resistance of the cable. As the data signaling rate is reduced below the 90 kilobit per second, the maximum cable length is limited at 4,000 feet or 1,200 meters by the assumed maximum allowable 66% signal loss at the receiver end. In region B, as the data rate increases, the cable length decreases to maintain the rise time and fall time requirements. The maximum allowable distance between a driver and a receiver is limited to about 50 foot or 15 meters. For signaling rate speed above the 10 megabit per second. For reliable communication, the maximum rise time or fall time of the driver should not exceed 1/3 of the total bit time at a given data rate. For example, a 1 megabit per second RS-485 driver has a bit period of 1000 nanoseconds. The maximum rise time and fall time should not exceed 333.33 nanoseconds. Tip 2. Obey the 1/3 rule. 1/3 rise time, 1/3 fall time, and 1/3 bit time for guarantee no data loss. In a noisy environment, use the 1/4 rule. 1/4 rise time, 1/4 fall time, and 1/2 bit time for a better performance. An eye diagram is a great way to visualize the attenuation effect caused by the transmission cable and check the 1/3 rule. In this first example, 4,000 feet of 24 AWG Cat5e cable is used between the driver output and the receiver input. On the left-hand side, you can see the input signal DI at 90 kilobit per second, as well as the output of the driver, which seem to show an almost instantaneous rising and falling edge. On the right-hand side, after the 4,000 foot or 1,200 meter of 24 AWG Cat5e cable, the receiver sees rising and falling edge that look like an RC delay due to the long cable pairs. However, the receiver is still able to successfully transmit the signal with no data errors. This is because the receiver is seeing the rising and falling edge that fall within the 1/3 rule we discussed earlier. In this example, the data rate is increased to 2 megabits and 4 megabits respectively. The rise and fall time in both cases exceed the 1/3 UI rule. Data loss at the receiver end is guaranteed to occur at this data rate over 4,000 feet of cable. The data signaling rate versus cable length graph indicate a maximum of 200 feet at 2 megabit per second and about 100 feet at 4 megabit per second. For a successful transmission, the maximum permissible length between an RS-485 driver and the receiver is 4,000 feet. However, both cable quality and the data rate impact this distance. As data rate increases, the signal gets increasingly attenuated by the parasitic RC filter created by the cable. Tip 3. Use a larger diameter cable to reduce the DC parasitic loss and improve signal performance over long distance. Per the RS-485 standard, the minimum drive string or VOD is 1.5 volt. To support a longer cable length, look for an RS-485 transceiver with a drive string that exceeds the RS-485 standard. In general, a higher drive string helps to counter the DC parasitic resistance of the interconnecting cable and to support further communication distance at a low data rate. Tip 4. Whenever possible, choose an RS-485 driver or transmitter with a higher VOD than the standard RS-485 specification of 1.5 volt. In summary, follow these tips to maintain a successful RS-485 length. Tip number 1. Use the TIE EIA 422B graph as a guideline for the maximum cable length. Tip 2. Obey the 1/3 rule for a guarantee of no data loss. In a noisy environment, use the 1/4 rule for better performance. 1/4 rise time, 1/4 fall time, and 1/2 bit time. Tip number 3. Use a larger diameter cable to reduce the DC parasitic loss and improve signal performance over the long distance. Tip number 4. Whenever possible, choose an RS-485 driver or transmitter with a higher VOD than the standard RS-485 specification of 1.5 volt. I hope you will consider these above tips when designing your next RS-485 design. For more information, refer to the RS-485 cable length plus data signaling rate application note. Contact our field application team or visit maxlinear.com. And thanks for watching this video.